actually getting into the main part of the unit and the stuff you'll do the most of on tests from here on out. Main part of the unit, yeah. So what we're going to do is we're going to start building equations. So equations that connect the lines and so on and so forth. The reason we spent all that time doing slope before is slope is a big part of finding and creating equations. So we spent all of our time figuring out rise over run and using 2 points to find the slope and parallel, perpendicular, all that jazz. Today, we're going to start off and we're going to learn about slope-intercept form. So that's just one of 3 different types of forms that we're going to learn about equations. Slope-intercept form is probably the most useful. So it's the one you see the most of. It's the one you probably see the most of going forward in math as well. The second one we do is slope point form, which is not very often used moving forward. It's a good skill to help you with something else in math, but it's not really used too often. And the third form we use is called general form, so that'll be lesson 5.6. Slope-intercept form. We're going to start things off by looking at 2 equations. This one is y equals 2x plus 1. It's also this line right here. Whoa, well, way off that time. So that line is y equals 2x plus 1. We're going to look at that line, and we're going to calculate 2 things on it. We're going to calculate the slope and the y-intercept. To calculate the slope, you find 2 points on the line. I'm just going to use this point and this point. You always work from left to right. You go up 2 over 1. That means the slope is 2 over 1. Otherwise, just 2. We're also going to calculate the y-intercept on this thing. So to calculate the y-intercept on this, you just look and you find where that line crosses this y-intercept. They cross right here. That point is at positive 1. That should hopefully be a reminder. Yeah, I don't know how to do that. That's easy. Okay, on the second line, I want you to do the same thing. So I want you to find the slope and the y-intercept of that second line. Do rise over run on the second line, and then do the y-intercept. Find out where it is and write down that out. The slope of this second point, you find 2 points on it. One there, there. You always work from left to right. This time, to get from the left point to the right point, I have to go down. So 1, 2, 3, 4, 5. Since I went down, we say negative 5. And to the right, 1, 2. That means the slope was negative 5 over 2. Always go left to right. It really helps your negatives, right? Just a reminder of rise over run. It helps your negatives go down. The y-intercept for this one is right here. It's at negative 3. All right, we're going to compare our answers to our equations. And hopefully you notice something. If you look at your slopes, the number 2 appears in the equation, and the number 5 over 2 appears in the equation. And they both appear in the same spot. They're both being multiplied by the x. The y-intercepts also appear in the equation. So if you look at 1, it's right there, and if you negative 3, it's right there. And you notice that they're both just constant terms. They're being added or subtracted to your x value. That's not a coincidence. Right? That's because these things are in slope-intercept form. Slope-intercept form is written in this general form right here. Y equals mx plus b. We call that the slope-intercept form. Where y is all by itself, there's a number being multiplied by the x, and then there's a constant being added on to the equation. What do you think m is? Slope, right? M always stands for slope. So in this equation, that's no different. The m value is the slope of any given equation. And that constant value, that b value that's just being added or subtracted on at the end, that is always your y-intercept. That means we could look at equations and really quickly be able to figure out the y-intercept and the slope, just given the circumstances. So like if you look down here in question A, and I said, what's the slope and what's the y-intercept? Hopefully you look at that and you realize that's in y equals mx plus b form. Y is by itself, everything else on the other side. There's a number attached to the x, and then there's a number added on at the end. This means that the slope equals 3, and the y-intercept equals 2. You can literally take equations and really quickly figure out both those things. For the second equation, that is in slope-intercept form, but it's a little bit different. The reason it's a little bit different is they've reordered it. So slope-intercept form usually is y equals mx plus b, but technically you can reorder addition and subtraction. So you could also write it as y equals b plus mx. That's what they've done in this question. They've reordered this thing. The trick is to realize that whatever number is being multiplied by the x, the one that's touching the x with nothing in between it, that'll always be your slope. The one that's either being added or subtracted that's kind of off by itself, that'll always be your y-intercept. There's another trick to this one. And the trick has to do with the negative number. So the slope is not 0.5, it's negative 0.5. And you do have to include it as a negative 0.5. The y-intercept is just positive 7. Some people get that negative mixed up, but the negative is attached to the 0.5, not to the 7. Question C. That thing is not in slope-intercept form. Why is C not in slope-intercept form? It's a variable in front of the y, right? Look at your formula. There's not supposed to be anything in front of the y. So 8 is not the slope and 1 is not the y-intercept because this is not slope-intercept form. The only way you can read slope and y-intercept is to change something in slope y-intercept form. So if we wanted this to be slope-intercept form, we would have to somehow move this 6 to the other side. How do you move that 6? If there's nothing between the 6 and the y, that means it's multiplying. So what's the opposite of multiplying? Dividing. So we need to divide every term by 6. And when you divide every term by 6, that'll leave you with y equals 8 over 6x plus 1 over 6. We did that because we wanted to create slope-intercept form. Slope-intercept form has y isolated by itself. No numbers attached to it. Now I can check my slope and my y-intercept. What's the slope?
8 over 6.
The slope is 8 over 6, the number attached to the x. And what's the y-intercept?
1 over 6.
1 over 6. Awesome. If this was a test question, this might not show up as my solution. Why would that maybe not show up as the solution? Particularly the slope, right? Yeah, you can reduce that fraction, right? 8 over 6 can be reduced. Remember, your calculators can do that for you. Go 8 divided by 6 in your calculator, hit enter, hit the math button, and then hit frac, and it should reduce it to 4 over 3. If you want to reduce it in your head, you just have to divide both numbers by something. They both divide by 2. Okay, how this might look in the question. We can now, with this knowledge, take equations and graph them by hand. So I could take something like this, and I could graph it by hand. The way I could graph by hand is by using my knowledge of slope and y-intercept. What's the slope of that equation? Correct, the number attached to the x. What's the y-intercept of this equation?
Or negative 5.
Negative 5, right? The constant on the end of it. This means I have a starting point. It's at negative 5. And my slope tells me how to get to other points on that graph. Slope is rise over run, so that means go up to, how much do I have to go over? 1, right? There's an invisible divide by 1 there. So that means my next point would be right there. And I could keep doing that. I could go up 2 over 1. Up 2 over 1. I could do a whole bunch of points if I wanted, or I could just connect them all, and I would have a beautiful line like that. So you can graph things by hand really quickly now, especially if they're in slope-intercept form. When you guys come back, we're also going to take graphs and create equations from them. Today, all we're going to do is graph things by hand. Next week, we are going to go backwards. We already marked the y-intercept in the grid. We already connected the dots. You could verify all of your graphs by putting them in your graphing calculator. So if you took this thing, you put it in your calculator, you set the same window I had, you would get the exact same thing. Remember your standard window is negative 10, positive 10, negative 10, positive 10. So make sure if you do verify, you check that at home or on your own, you put in your calculator with the same window that we have here. You should get the exact same one. All right, we'll do one more together. I want you to try to fill out the first part, but instead of stating the y-intercept, state the y-intercept and state the slope. So for that equation, I want you to write slope equals and y-intercept equals. This is in slope-intercept form, right? Y equals mx plus b. Definitely looks like it's in that form. The slope is m, which is 2 over 3. And the y-intercept is b, which is negative 6. For part B, it says, determine the x-intercept algebraically. If you want to figure out the x-intercept algebraically, what do you know about all x-intercepts again? A little bit of review. Y is 0. So that means we change y to equal 0. When you're looking for an x-intercept algebraically, that means you change y to be 0. So if you go back to your equation, you change y to be 0. And this is probably a little bit of good review for our algebra skills, because they're going to come very in handy later in this unit. Because we're going to have to move things around to change forms. And we are going to do that. We're going to change forms once we learn all 3 of them. We need to solve for our x-intercept, which means to get x by itself. If you want x to be by itself, you need to move everything to the other side of the equal sign. To move things from one side to the equal side to the other, you do the opposite operation. So the opposite of negative 6 would be plus 6. That would give me 6 equals 2 divided by 3x. Right, you always move additions and subtractions first, if they're separate by themselves. Then, you need to get rid of any divisions you might have. I have a divide by 3 here. What's the opposite of divide by 3? It times by 3. That would cancel out this side. 6 times 3 is 18. And I'm still left with 2x. So I got rid of the divide by 3 by multiplying the other side by 3. If I want to get rid of a times by 2, which is what I'm left with, what's the opposite of times by 2? Dividing by 2. And the opposite operation is how you move things from one side to the other side. That means 9 equals x. That means I have an x-intercept right here. I'm going to draw my x-intercept. I'm also going to draw my y-intercept, which I figured out in the previous question in part A. And anytime you have 2 points, you can connect those lines to create a linear equation. Now, how could I check to see if that linear equation is actually this one right here?
You could go and use the slope, go from -6.
Perfect. This equation had a y-intercept of -6, which is correct. I could then use the slope of 2 up and 3 over to see if it would actually lead me to this point that I just found. If we try that, we go 2 up, 1, 2, and 3 over. 1, 2, 3. That's 1 point. I go 2 up, 1, 2, and 3 over. 1, 2, 3. That's another point. 2 up, 1, 2, 3 over. 1, 2, 3. It actually gets to the x-intercept that I calculated. So you can see this is the proper equation. I did do my math properly here, so that is good. And you can double check things, right, with your knowledge. That's kind of the usefulness of understanding what a slope-intercept form is. Really easy to check graphs and see if you've done things right. Also a quick and easy way to find other points on an equation. All right, the next question. This is when we'll start to create equations. So we're going to take info, create equations, take graphs, create equations. But that'll be saved for part 2 of this lesson, which will be Tuesday. Okay.